Okay, welcome back, and we're heading into the pre-processing section of our guided project on decision trees, and we're using the heart failure dataset from Kaggle. So the first thing that we want to do is check if there are any null values. So a quick simple way to do this is df.isNull parentheses dot sum, and this will give us a nice series of with the column names as the index of how many null values there are. And we can see here that there are no null values in this data set. So that makes the pre-processing section a little bit easier, although filling null values is not difficult. So what we'll do is we're going to look at a few of the data sets. So we'll see here, we're going to start with cholesterol. So we're doing a dis plot from seaborne, and we'll see we're saying data t equals df, x equals cholesterol. So we can see here we have quite a few outliers on the right-hand side. So what we'll do is we'll go df cholesterol, and then that is equal to df cholesterol. Make sure that we're spelling it right. Cholesterol. Okay, but what we want to call on this series is dot clip, and what we want to do is call the argument upper. So we set the upper bound of where we're going to clip this. Looking at this, maybe somewhere right in between 400 and 500 would be good. Maybe let's set it at 450. So we're still saving some texture to our data set, but we're reducing those outliers as those really do have a bit impact on our final model. So let's look at this again. So if we go sns.displot data equals df, and what we're going to do is x equals to, copy this, cholesterol. So we'll put in the cholesterol feature here. Take a look at that, and we can see here, got a nice, much more condensed data frame. We got rid of those outliers on the right-hand side. And we could do something about these outliers on the left-hand side, but we're going to leave it as is for this data set. Okay, so we're going to look at old peak next. And so to get a plot of this, we've run through this already. And so we're going to go displot data equals df, x equals, and we're going to look at old peak. So if we run that, you can see here we have outliers on either side. So we're going to look at treating those. We'll do it the same way here. So we'll df old peak is equal to df old peak dot clip. So we're going to clip this again, but we're going to call this a little bit different. We're going to do two sides to this now. So we're going to go lower equals to, if we look at this, I would say moving it pretty close to 0 would be a good amount. We just want to get rid of these negative numbers. So let's go negative point. I'm going to say 0.2 or let's go 0.5, negative 0.5, and let's do the upper. I think we would probably set this at 4. Upper equals 4. Okay, so let's run this again. I'm just going to copy and paste this down below. So if we're looking at the distribution plot of the old peak again after we've done the clip, you can see here much neater, much more, not uniform, but a much more compact data frame. This is much better for our models. So the next thing we'll do is we'll look at creating some dummies, one-hot encoding our features. So we'll take a quickly look at the DF, the features that we're looking at using. So we can see we have sex, chest pain, resting ECG, exercise angina, and the ST slope. Those are all good categories for one-hot encoding because we identified them right in our first set when we did the df.describe include objects. There are not too many different categories in each one of these data sets. So we'll look at it here. So we're creating a list of our categories, and what we'll do is we'll then put this into, so we go df equals pd dot get underscore dummies, and we're going to go df, and we want to pass this columns, and we want to give it the list of our categories. So we'll give it the list here, and you can see df is our data frame that we're passing to the pd.getDummies, and this will return a data frame. Oh, and we just got to run this list of category features first, and then there we go. We get a nice list of this. So what we're heading into, or we're going to start heading into the the modeling section, but before we do, we want to do the train test split. So what we'll do is I like to start off by looking at the columns so we can have a list of our columns. You can see here all the one-hot encoded. If you're a student, you would have access to this workbook and you would already have these filled in just to save a little bit of time. But I'm basically just copying and pasting this and putting it there and then putting heart disease in a separate list. So we'll get both of those lists created and we'll go df.features, which are a list of features for our model, and then df and then in brackets target, and that's going to be the class or our target feature. So get that done. And then what we want to do is the test train split. So we'll go x train dot x, or sorry, x test y train and y test. So this is going to be equal to the train test split. And what we're going to do is we're going to give it x that we just created in the cell above, y, and I like to set the test size to 0.3. Oops. So 0.3. And what we'll do for reproducibility, we'll set the random state equal to 42, just so that we can our model will be trained on the same data set. And especially for classes, this is really good for reproducibility.